This video contains the solutions to your 5-5-5-8 multiple choice practice questions. Number 1 is an analytic geometry maximum-minimum type question. We're given the curve x squared plus 2y equals 0, and we want to find the point on the curve that is nearest to this point, 0, -1/2, happens when y is equal to question mark. Okay, so let's see if we can figure that out. Here we've got y is equal to -1/2 x squared, solving that. So if I wanted to do a distance function, we're talking about the distance between a point on this function, which would be a point x comma y, and a point on this function. So that would look like this. Distance formula: square root of x minus x squared plus square root of y minus y squared. And I'm going to do a little simplifying here so that my derivative will be a little bit easier. Why am I talking about derivatives? Because I want to minimize the distance, right? If we want it to be closest, that's minimum distance. So let's see, that's x squared plus, foiling this out, you get 1/4 x to the 4th. I think that's that piece foiled out, and then I get 2 of these minus 1/4 x squared, which makes minus 1/2 x squared plus 1/4. And simplifying that again, we have 1/2 x squared plus 1/4 x to the 4th plus 1/4. And if you rearrange, I don't know, you may or may not, should have written that term first. That's actually the square root of, did you notice this? When you add the x squared, it just changes the sign of the middle. That's 1/2 x squared plus 1/2 squared, which is that. That's the fastest way to get there. If you realize, sorry, I don't know if you can see that. There we go. If you can see that, that's what's happening there. But let's pretend we didn't see that. See what happens. Let's take the derivative of this in this form. So we have 1/2 times 1, I'll put that term first, x to the 4th plus 1/2 x squared plus 1/4 and -1/2 times the derivative of what's inside, which is 4 times 1/4 is 1 x cubed plus x, right? That's that times the derivative of what's inside. Now we need this to be equal to 0, so because we're looking for a minimum. So that's 1/2 times, this is all on the bottom, right? This is the square root of this thing on the bottom. So whenever, as soon as you realize that it's going to be on the bottom, we know this can't make it equal to 0, right? It's the top being equal to 0 that makes it equal to 0. So I need to set that equal to 0. So x cubed, that's x squared times x plus 1. That happens at x equals 0, x equals -1, and which one is the real minimum value that we're looking for? If you think about the graph of this, this is a parabola that opens down like this, and we're looking for where it is closest to the point 0, -1/2. And I suppose we could just check those points. This is the point 0, 0, right? This is 0, negative 1/2. And then what would you get if you plugged negative 1 in for the x? You'd get 1 plus y would have to be negative 1/2. So that'd be negative 1, comma, negative 1/2. So which one's closer? Looks like this is 0 distance away, and this is 1 distance away, so this is closer. So what's the y coordinate? At the closest point, it's 0. If you can use your calculator, that's a whole lot faster, right? You check this out, find that minimum distance, and a much faster problem. And that's from an old test. You don't see many like that anymore. Number 2. Oh, and that was what? Sorry, that was answer choice B. Number 2. Point moves on the x-axis in such a way that its velocity is given by v is equal to the natural log of t over t. And we want to find at what value does v attain its maximum. We want to find maximum of v. If we want to find the maximum of something, we need to find the derivative of that thing. So we need to find the derivative of v. Let's see, the derivative of that, which is acceleration, by the way, is low d high minus high. D low is just 1 all over low, low. And since I'm looking for a maximum, I'm going to set that equal to 0. That's 1 minus the natural log of t. T squared equals 0. Only thing that can make that equal to 0 is the top. So that's will be natural log of t is equal to 1. Oops, sorry, I said 1 and I wrote a 0. And that's e to the 1, so that will be t would be 1, right? I'm sorry, e to the 1 is e. T would be e. And that's the only value I'm getting, so it would just remain to make sure that, to check that it is a maximum. Because notice that there is no maximum. So we just set up a quick number line here. There's our e. Check something on either side and make sure that we're getting a maximum here. So plug in something less than e, like 1. It'd be 1 minus the natural log of 0, which is 0. 1 minus the natural log of 1, which is 0. That'd be positive on top, positive on bottom. That's increasing. And then pick a number above e, like, I don't know, I guess e squared would be easy enough. So 1 minus the natural log of e squared is 2. So that's negative over positive. So that's increasing, decreasing. So sure enough, that's a maximum. So it happens at e, which is answer choice C. Number 3, we're looking for, let's see, the mean value theorem guarantees the existence of a special point on the graph of y equals the square root of x between 0, 0 and 4, 2. They want us to find that point. Well, the mean value theorem says that average slope, which is y minus y over x minus x, right? That's our average slope, is equal to the exact slope, which we get by the derivative. So average slope is equal to derivative. The derivative of that would be 1/2 x to the negative 1/2. So we need to find that value. And it should be a value in between 0 and 4, right? That's what the mean value theorem says. So I can divide the 1/2 out, and I get 1 is equal to x to the negative 1/2. So x is equal to 1. And sure enough, that's in between there. They wanted the point. It would be the point 1 comma the square root of 1 is 1. So the point 1, 1, and that's answer choice B. Gotta love the mean value theorem. Number 4 is accidentally the same as number 1. The answer is still 0. Number 5, a point moves in a straight line so that its distance from a fixed point on the line is 8. I'm going to just write it as a distance, like a position function, is 8t minus 3t squared. They don't do that too much on the, this again is from an old test, but they didn't do that too much where they don't give you this, right? But it would, they're talking about a position function here. So they want the total distance covered between time 1 and 3. All right. Well, we got to make sure there's no turnarounds here. So the velocity function, why am I finding the velocity function? I'm trying to see if it turns around ever between 1 and 2. So let's see. The derivative of that would be 8 minus 6t, and that means the velocity would be 0. In other words, there's a turnaround point at t equals 4/3. Sure enough, that's in between these. So what I need to do, this is just like your homework, just like your video notes from section 5.8. I need to find, I need to find the position at 1, the position at 4/3, because it's turning around there, and the position at 2, and find the total distance. So let's do that. The position at 1, when I plug 1 in here, is 8 minus 3, or 5. Position at 4/3, let's see, that would be 8 times 4/3 minus 3 times 4/3 squared, which is 16/9. And let's see, that's 32/3 minus 16/3, which is 16/3. And the position at 2 is, let's see, 2 times, that would be 16 minus 3 times, or 16 minus 12, which is 4. Well, since this is in thirds, I guess maybe I could do this. 5 is the same as 15/3. 4 is the same as 12/3. So how far did it travel from here to here? From here to here, it went 1/3, and from here to here, it went 4/3, right? 1/3, and then 4/3 from here. Total distance, we don't care if it's going forward or backwards. We want the total distance. So adding those together, I get a total distance traveled of 5/3. Just like you should have been doing in the homework from 5.8. And that's answer choice C. Number 6, another one of our distance formula type problems. See if we can do that again. We've got the point on y equals 1/2 x squared nearest to 4,1. Alright, let's see if we can find that. So I'm going to set up my distance formula again. Points on this look like that. So I'm trying to do the distance between these. X minus x plus y minus y. Oops, minus. Excuse me. And let's simplify that first. I think it's going to be easier in the end if we do that. So that's the square root of x squared minus 8x plus 16 plus, foiling this out, is 1/4 x to the 4th minus, I get a couple of negative 1/2, so that's minus x squared plus 1. And see if we can simplify that. Look, the x squareds cancel out. So I get 1/4 x to the 4th minus 8x plus 17 all to the 1/2 power. Okay, now I'm going to take the derivative and try to find that minimum distance. So that's 1/2 times 1/4 x to the 4th minus 8x plus 17 all to the negative 1/2 times the derivative of what's inside, which will be x cubed minus 8. And like the last problem, all this stuff, this is on the bottom, so this actually can't make it equal to 0. I've got 1/2 times this is all square root on the bottom, can't make it equal to 0, right? That can only make it undefined, and then the only piece that can actually make it 0 is this. So setting the top equal to 0, I've got x cubed minus 8 equals 0, x cubed equals 8, so x equals 2. Not plus or minus 2. It's cubed. It's only 2, right? Negative 2 cubed is negative 8. So at x equals 2, and it just remains to check that it really is a minimum distance. But if you look at the, I mean, if that's our only option, I think it must be happening at the point 2, comma, if you plug 2 in here, you get the point 2, comma 2. And that is answer choice B. Number 7, we've got position of a particle moving along a straight line at any time t is given by this position function. I use the s this time for position. We've seen that before. No bother. Plus 4t plus 4. And they want to know what's the acceleration of the particle when t equals 4. Well, the velocity would be the derivative of that, 2t plus 4. The acceleration would be the derivative of that, which is 2. So, well, the acceleration is constant at 2. So the acceleration at 4 is the same as the acceleration everywhere else. It's 2, which is answer choice B. That was easy. And number 8, we've got another position function. Position is negative 5t squared. Then the average velocity from 0 to 3. Average velocity. Average. That means we're actually finding slope using 2 points. So the position at time 0 is 0. Position at time 3 is negative, let's see, negative 5 times 9, negative 45. So the average velocity is the s sub 3 minus s sub 0 over 3 minus 0. It's the actual slope connecting those 2 points. So that's negative 45 minus 0 over 3 minus 0, which is negative 15. Look out for that word average. Average rate of change, average velocity means you're actually finding a slope. And notice, I betcha if you find the derivative of this, let's see, the derivative would be negative 10t. Is negative 30 a choice? Oh, it is. Answer choice B. If you plug in the 3 there, you are going to get answer choice B. And you could try to figure how they figured out those other wrong answers, but it's not what we're supposed to do because we're finding the average rate of change. Number 9, let's see, another mean value theorem. I've got the function x cubed minus 3x squared, and they want to know what are all the values of c that satisfy the conclusion of the mean value theorem on the interval 0, 3. So that means I need the point 0 something and 3 something. I'm going to find the average slope and then set it equal to the derivative. So let's see. When I plug 0 in, I get 0. When I plug 3 in, I get 27 minus 27. I also get 0. So the slope between those, well, they're on the same horizontal, so the slope is actually 0. I'm going to set that equal to the derivative, 3x squared minus 9x. So where's that equal to 0? A little factoring there. 3x is x minus 3. That's equal to 0 at 0 and 3. No, I did something wrong. Hold on. 3 times 2. Ha ha ha. That's not 9. That's 6. Sorry. 0 and 2. Now that seems like 2 answers, although if you look at the answer choices, 0 and 2 is not a choice. So when we think about it, the conclusion of the mean value theorem actually says we've got to, if we're looking between 0 and 3, we're going to find an answer that's in between 0 and 3, but not including 0 and 3. So that's the one that's guaranteed by the mean value theorem. The endpoints don't count. They could incidentally be the same slope, but it actually guarantees another one inside the interval. I mean, that's a little bit stronger conclusion. There's got to be one in between. All right. Number 10. Particle moving along the x-axis so that its position is given by the function t e to the negative 2t. Negative 2 up there, so I'm going to have some product rule and chain rule going on here. For what values of t is the particle at rest? Well, at rest means velocity is 0, right? That's what that means. At rest would be when the velocity is 0. So let's find the velocity and set it equal to 0. The velocity is the derivative of this. So, using the product rule, the chain rule, the derivative of the first is 1 times the second plus the first times the derivative of the second. The derivative of e to the whatever is e to the whatever times the derivative of what's inside. Alright, let's set that equal to 0 and do a little factoring. I can factor this out. We've seen this game before. That leaves a 1 there and a minus 2t here. That can't be equal to 0. In fact, it's always positive. And that gives us a value of t equals 1/2. So looks like it's turning around or at rest at 1/2 only. I guess they put the answer choice E, the 0 and 1/2, was for the person who might think that somehow 0 made this equal to 0, but e to the 0 power is 1, right? You can't make that 0. It's crazy. All right, there you go.